In this presentation on real numbers, we are going to discuss a test to check whether a given rational number is terminating or a repeating decimal number. So suppose we are saying that x be a rational number whose simplest form is p by q. This term simplest form is important over here, that the rational number that should be in the simplest form. And by the definition of rational number, we have p and q are integers and q is not equal to 0. Then we have two conditions. The first condition we have is that x is a terminating decimal only if q is of the form 2 raised to the power m into 2 raised to the power n. That is, we are talking about, we look at the denominator of that number, and if it has only factors 2 and 5, then that number, the prime factors we are talking about, it has the only prime factor, they are 2 and 5, then that number has terminating decimal representation. And if we are saying that the given number, it is not of the form 2 raised to the power m into 2 raised to the power n, it means that it has some other factor, other prime factors except for 2 and 5, then that number is non-terminating and repeating decimal number. So we look at some examples over here. First is, without actual division, show that each of the following rational numbers is a terminating decimal and express each in the decimal form. Now the first example we have, it is 31 by 2 raised to the power 2 into 5 raised to the power 3. Now first thing that was there in the condition, it was that the given number should be in the simplest form. So we can see over here, this numerator we have, it is 31 over here, and the denominator has prime factors 2 and 5. It means the HCF of numerator and denominator, it is 1. So we are saying that clearly none of 2 and 5 is a factor of 31. So it means that this given number, it is in the simplest form. So first of all, you have to check whether it is in the simplest form or not. Now the denominator that we have, it is 2 raised to the power 2 into 5 raised to the power 3. So it is in the form 2 raised to the power m into 5 raised to the power n. So we are saying that the given number, it is a terminating decimal number. So the given number, it is a terminating decimal number. Now if we have to find the value, the second part of the question, it says express each in decimal form. So if we have to represent it in decimal form, so we are saying we have 2 by 31 by 2 raised to the power 2 into 5 raised to the power 3. So if suppose we multiply the numerator and denominator of this number by 2, so we will get, the numerator will become 31 into 2. Now the denominator, when it is multiplied with 2, look at this term over here, it is 2 raised to the power 2. When we multiply denominator with 2, it will become 2 raised to the power 3. So we are writing it is 2 raised to the power 3 into 5 raised to the power 3. Now numerator is equal to 62. Denominator is 2 into 5 raised to the power 3. 2 into 5, it is 10 raised to the power 3. So we are saying this is equal to 62 by 1000, that is equal to 0.062. The next we have is the number 41 by 1000. Now we have to check without division whether it has a terminating or non-terminating representation. So we look at this denominator over here, it is 1000. If we do the prime factorization, we will obtain that this is equal to 8 into 125, that is equal to 2 raised to the power 3 into 5 raised to the power 3. This is the prime factorization of number 1000. Now clearly we are saying that 2 and 5, they are not the factor of 41. It means that the given number, it is in the simplest form. So what we have obtained now is that 1000 we are having, it is equal to 2 raised to the power 3 into 5 raised to the power 3. It means it is of the form 2 raised to the power m into 5 raised to the power n, where we have m is equal to 3 and n is equal to 3. So what we obtain is that the given number is a terminating decimal number. And the value of this number, we have 41 by 1000, and that is equal to 0.041. Next is the number 17 by 625. So 625, we can write it is equal to 5 raised to power 4, and clearly 5 is not a factor of 17. So the given number, it is in the simplest form. Now if we look at this number, we are talking about 5 raised to the power 4, then it is of the form 2 raised to the power m into 2 raised to the power n, where the value of m we have it is 0 and the value of n we have it is 4. So we are saying that we can write this number in the form, 2 raised to the power 0 into 5 raised to the power 4. 2 raised to the power 0, we know it is equal to 1. So it means that the given number will have a terminating decimal representation, and to find that representation, we are writing 17 by 25. We are saying it is 17 by 5 raised to the power 4. We multiply the numerator and denominator by 2 raised to the power 4. We have 17 by 5 raised to the power 4. So 2 raised to the power 4, it is 16. The numerator will become 17 into 16, and the denominator we have it is 2 into 5 raised to the power 4. 2 into 5 raised to the power 4 means 10 raised to the power 4. 10 raised to the power 4 means we are talking about the number 10,000. So when we write this in decimal form, we get it is 0.0272. So this is the decimal representation of this number. Next is, without actual division, show that each of the following rational numbers is a non-terminating repeating decimal. Now the first number that is given to us, it is 121 divided by 2 raised to the power 3, 3 raised to the power 2, and 7 raised to the power multiplied by 7 raised to the power 5. So when we look at this number, we are saying that none of the 2, 3 and 7, we are talking about the denominator over here, none of these numbers, it is a factor of 121. It means that the given number, it is in the simplest form. It means the given number, it is in the simplest form. Now if we compare the denominator with this form, we are saying 2 raised to the power 3, 3 raised to the power 2, 7 raised to the power 5. This is the denominator, and this number, this denominator, it is not of the form 2 raised to the power m into 5 raised to the power n. It means that this given number is a non-terminating repeating decimal number, because the denominator, it has the factors other than 2 and 5. Next is the number 17 by 90. Now if we look at the denominator over here, it is 90, and we are saying that we can write 90 is equal to 2 into 3 raised to the power 2 into 5. You can write 90 in this form. And this number 17, the numerator we are talking about, it is prime. So we are saying none of 2, 3, 5, they are the factors of 17. It means that this given number is in the simplest form. Now what we have is that 90 is equal to 2 into 3 raised to the power 2 into 5, and we are saying this is not of the form 2 raised to the power m into 5 raised to the power n, because there is another factor, prime factor 3 over there. So what we obtain from this is that 17 by 90 is a non-terminating repeating decimal. It will have a non-terminating repeating decimal representation. Next number is 66 upon 180. So if we Look at the numerator and denominator is 66 and 180, and we have HCF of 66 and 180. It is equal to 6. It means that this number, it is not in the simplest form. So first of all, we are going to convert it in the simplest form. So we are writing it is 66 by 180. We are going to divide the numerator and denominator by 6. We are dividing the numerator by 6. We are dividing the denominator by 6. And this numerator, it is 66 divided by 6. The numerator will become 11. And when we are talking about this denominator, it is 180 divided by 6. Denominator is 30. So we are saying the simplest form of the number 66 by 180, it is 11 by 30. Now we are talking about this number 11 by 30. Now if we try to find the prime factors, we obtain that 30 as the factor, it is 2 into 3 into 5. And clearly this 2, 3 and 5, none of these values, it is a factor of 11. It means that this number 11 by 30 is in the simplest form. And as the factors of 30, they are 2 into 3 into 5. So they are not in the form 2 raised to the power m into 5 raised to the power n. It means that this given number 11 by 30 and hence this number 66 by 180, both these numbers, they are having non-terminating repeating decimal representation. Now the next question we have is the decimal expansion of the rational number. This rational number is given. It is 43 by 2 raised to the power 4 into 5 raised to the power 3. Will terminate after how many places of decimals? So first thing, it is clear that this number, it is in the simplest form. This number, it is in the simplest form. And moreover, we are saying that this number, we have a terminating decimal representation because the denominator we have over here, it is of the form 2 raised to the power m into 5 raised to the power n, where m is 4 and n is 3. So when we are talking about this number, it is 43 divided by 2 raised to the power 4 into 5 raised to the power 3. To make the powers of both these numbers same, the power over of 2 is 4, 5 is 3. To make this power same, we are going to multiply and divide this number with 5. So now the numerator, it will become equal to 215. The denominator will become 2 into 5 raised to the power 4. Now 2 into 5 means we are talking about the denominator, it is 10 raised to the power 4. The numerator, it is 215. The answer we obtain, it is 215 by 10,000, and the value comes out to be 0.0215. So we are saying that it will terminate after 4 places of decimals. Now next, we are given two numbers. One is this number and second is this number. And we have to tell whether both these numbers, these are rational. And if these are rational, then we have to tell what will be the prime factors of their denominator if we write these numbers in the form p by q. So we are saying that this first number we are talking about, it is a terminating decimal. So if it is a terminating decimal, it means it is a rational number. And because it is a terminating decimal, it means that when we write this number in the form p by q, then the prime factors of the denominator will be 2 or 5 or both. It means the denominator that we will have, it will have prime factorization of the form 2 raised to the power m into 5 raised to the power n, where m and n, we are saying these are the these two numbers, we are saying these are the whole numbers, or we are saying m and n, they are non-negative integers. Next, regarding this second number, we are talking about the second number. We have 32.1, 2, 3, 4, 5, 6, 7, 8, 9, and we have bar over there. So this number is a non-terminating but repeating decimal. So it is a repeating decimal. It means again it is a rational number. And because it is repeating decimal, it means that the prime factors of the denominator are other than 2 or 5. It means that if we do the prime factorization of the denominator, it will not be of the form 2 raised to the power m into 5 raised to the power n, where m and n, these are non-negative integers.